All right, folks, in today's class, we're going to be talking about polynomials, and specifically, we're going to be talking about collecting like terms. A polynomial is something with many terms, many nomials terms. What's a term? A term is a part of an equation that's separated by a addition sign, a minus sign, or an equal sign. So if we look at this equation, we see that there are quite a few terms. Our output, f of x, is a term. X squared is a term. You see the equal sign, the addition, 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 and addition. So everything that's separated by addition and this equal sign, these are all separate terms. So a term, x squared is a term, 2x is a term, 4, 3x, 1, and 2x squared are all terms. Now what we're going to be doing today is we're going to be simplifying this equation by collecting like terms. And let me remind you, we're going to use algebra tiles to help us understand what we're doing. So remember that a small square equals 1, and a shaded square equals -1. A rectangle is x, and a shaded rectangle is -x. A large square is x squared, and a shaded large square is -x squared. So all we're going to do is we're going to use algebra tiles to represent our equation. So there's an x squared, so I'm going to use an x squared, and I'm going to run out of room, so I'm going to have to do this imaginatively. So here we have 1x, here we have 2 x's, 1, 2, 3, and 4. And when I'm using algebra tiles, anything that's red is a negative. It corresponds to shaded. So that's 1, 2, and 3. Let me add in, now that's that 1 that's right there, 1. And then 2x squared. I'll do this down here at the bottom. 2x squared. So x squared, x squared. 2 x's, 2 x's. 4, 1, 2, 3, 4. 3x, 1, 2, 3. Positive 1, positive 1. 2x squared, 1, 2. Now, what I'm going to do to collect like terms is we're just going to count up everything that's the same. So all of my x squareds, all of my x's, and all of my 1s, we're going to count up and see what we have. And we're going to go from there. 1, 2, 3. So let me actually move this down, and I'll put everything right down here. So that's 3x squared. And let me write in my f of x, because this is an equation. So 3x squared, those are done. I'm going to move those out of the way so I don't recount them accidentally. 1, 2, 3, 4, 5. These are all positive, so it would be positive 5x. Move all of these out of the way. 1, 2, 3, 4, 5. Positive 5. So that's 3x squared plus 5x plus 5. Now the last thing I want us to do as we're doing our work today in collecting like terms is we need to be able to identify what's going on here. So here we have, this is called, what we end up with is standard form of a quadratic function. It's quadratic because one of our x's is squared. This is a quadratic function. If we graph this, we would get a parabola. So what we need to understand is the terms. Each one of these terms has a name, and then each one of these coefficients also has a name. So we had x squared, so this is a term that's separated by a equal sign and a positive sign. So this is the quadratic term. So the quadratic term is the one that has the x squared. This is the quadratic term. So I'm simply going to write 3x squared. Excuse me. Now, the linear term would be very, very similar to our m times x in our slope-intercept form, y equals mx plus b. M times x would be the linear part of that equation, and this is the linear part of the quadratic equation. So this would be 5x. So if I could just cover this up, that looks like slope-intercept form, mx plus b. So this part, 5x, is our linear term, and then 5 is our constant. Now we also need to know the coefficients. How many x squareds did I have? How many of these x squareds were in this equation? I have 3. So I'm going to write 3. This is the quadratic coefficient. It's the number of x squares. And then how many x's did we have? How many x's did we end up having? We had 5. And then the constant is a little bit tricky because it's both a term and a coefficient. So the constant is 5 because there were 5 ones. Now let me do one last thing before I let you go. If I have this on my board, or on my desk, or on my notebook, or in a problem, negative x plus x plus x. So what I have here is negative x plus 2x. Sorry, that's not an x, that's a 2. Negative x plus 2x. Well, what does this equal? If I collect like terms, if I simplify this, what's a negative and a positive make? When I add them together, a negative and a positive. What's 1 minus 1? 0. What's 8 minus 8? 0. What's negative 12 plus 12? 0. So when my signs are opposite and I combine like terms, when I add them together, negative x plus x makes 0. So this will equal simply 1x. And this right here, just in case you've forgotten when you've done algebra tiles in the past, anytime that I add two pieces together that are opposite signs, this equals a 0 pair. 1x minus x is 0. And that works with ones, and that works with x squareds as well. X squared minus x squared is 0. 1 minus 1 is 0. X minus x is 0.
All right, Dragons, welcome to Virtual Algebra Tiles. There is a website which I will have linked on my calendar. If you could see it up here, this is media.mivu.org, blah, blah, blah. The link will be quicker, but this was a nice virtual algebra tile website that will let us play with it, and we won't have tiles falling all over the floor, and you get instant feedback. So what I wanted you to do is watch me do a couple of problems, and then I'll tell you what I want you to do on your handout. So we're going to go over here to simplifying expressions. And you can tell right now that if I look right here, it's in the easy category. So it's a two-step process. Step one, they're going to give you the expression, and you're going to drag your algebra tiles over into this area so that it reproduces the original expression. So in this case, I'm given negative x plus 5x. So using the key over here, the negatives are red and the positives are not. We're going to drag over a negative x. Well, those are my rectangles, so I'll drag one over there and just drop it anywhere. It really doesn't matter. Now notice down here, it tells us what we have, and if you compare, if your eyes are constantly comparing the original problem with what you've done down here, you should see the same expression come to fruition. So here we go. We got plus 5x. So I got 5 of the positives. So I'm just going to start dragging it. Notice it's keeping a tally over here. It's not in the same order as the original problem. We're not worried about that right now. Matter of fact, we won't ever be. But if you notice right here, I've got a positive 5x, and that's what I have right here. It's a positive 5x. And I have minus x. Minus x is the same thing as negative x. So you notice right here I got a big check mark on step 1. So a big check mark on step 1 means that you're doing well. So we'll go to step 2. We're now going to combine like terms to simplify the expression. Now we know that opposites add to what? What did Mr. Valdez say? He said opposites add to 0. So if I take opposites, one positive and one negative, this is really cool, what I like about this. If we take them and combine them, and I'm just going to drag one on top of the other. You ready for this? And we let go. Oh my goodness. They went to zero. They disappeared. So now you notice that there are no more zero pairs out here. These are all positives. You notice I have a check mark over here on step 2. So I now know that when I combine a negative x plus 5x, I get 4x. That was an easy one. Let's go over here and let's change the difficult to maybe medium. All right, so now I'm just going to take it one term at a time. If you remember, Mr. Valdez said that terms are separated by plus and minus signs. So if I look up here, I've got 1, 2, 3 plus signs. So 3 plus signs make 4 terms because there's 1 on either end. So if you want a quick way of knowing how many terms you have, add up your plus and minus signs and then just add 1 more to that, and that tells you how many terms. So I have 3 plus signs, 3 plus 1 more is 4. That means I have 4 terms. Here we go. Negative 3x, what color? That's right, negative. X's are these. Notice down there I've got negative 1, negative 2x. No, that's not quite what I need. I need 1 more. Notice down here, negative 3x, negative 3x. Good. All right, what's my next term? Positive 1. 1s are the itty bitties. All right, notice again, do a quick check. I got the same thing down here as I do up there. Plus an x, so I'll drag a positive x over there. Now again, they put it in a different order. Just make sure you have the same sign in front of your terms. In front of this 3x, I've got a negative. What do I have down here? I've got a minus, which is the same thing as a negative, adding a negative. All right, and what's my last term? Another plus 1. So I have a check mark. That means that I have modeled the expression properly, and now we're going to go looking for opposites. Are these two guys right here opposites? No, they're the same. So even if I try to drag one on top of the other and make one go away, it doesn't disappear because they're not opposites. So if I come over here and say, oh, maybe this guy right here with any of them, doesn't really matter, what do opposites make? Oh, they make 0. All right, so you notice right here a check sign on step 2 means that you're done. So how many negative x's do I have? I have 2 of them. I got negative 2x, and it's shown down here. And then I have a plus 2. I got positive 2 itty bitties. And notice that I can't combine these. I can't combine a square and a rectangle because they're not like terms. They will never cancel. It's got to be the same shape, and it's got to be opposites for it to cancel and go to 0. And let's do a hard one here. And it's really not that hard. You notice we get to x squared. So we got 5x squared. So I'm going to see how fast I can drag this over without a mouse. And again, I'm just kind of throwing them over real fast. There we go. I got 5x squared. What's my next one? Plus 2x. Plus is positive, so I'm not going to use reds. I got that. Okay, check down here. I'm doing okay. Minus 5. Just minus 5. I got those negatives. All right, and I can just drag them anywhere I want to over there as fast as I can, just so I can model these things with algebra tiles. And then what I have, plus 3x squared. So I got 3 more of these x squares. So I'm putting those over there like that. And then what do I have? Plus 3x. 1, 2, 3. I don't want that guy to hide. So I'll just bring that down. Okay. And the last thing, what do I have? I have plus 5. So there's 1. There's 2. Let's make everybody. Oh, I made them go away already. Oh, I didn't mean to do that. 4. I lost track. I don't know if I messed this thing up. Let's see. I'm going to do minus. Let's see if I can go back here and put my minus 5 back up here right there. And then now let me do my, yeah. So when you're doing this, don't make 0 pairs until the very end. Ah, I finally got my check mark here. All right, so I got my 5x squared. I got 5, 2, 3, 4, 5 big blue squares plus 2x. That's 2 green ones. Minus 5. That's the 3 or the 5 negative small squares. Plus 3x squared. I got 3 more blue guys down here. Plus 3x. I got 3 more green guys right here. And then plus 5. Those are the yellow guys. All right, so now where are my opposites? Do I have anything that will cancel out the blue guys? No. Do I have anything that cancel out the green x's? No. But these guys right here, when I drag them, they're going to make, I can make multiple 0 pairs. And finally, oh, there we go. So look what we have. We got 1, 2, 3, 4, 5, 6, 7. We got 8 x squares. There we go right there. And then we have the 5 x's. All right. So what I want you to do is I want you to go to this website, and using your handout, what I want you to do is I want you to do, I would like for you to just do the hard ones because in my opinion, they're really not that hard. So I'd like for you to go to the hard setting, and whatever problem they give you, I want you to write that down at the top of each of those boxes. And then I want you to come through and identify what your quadratic term is, your linear term. As a matter of fact, let's do this right here. Down here at the bottom, my quadratic term is 8x squared. My quadratic coefficient is 8. My linear term is 5x. My linear coefficient is 5. And do I have a constant? Well, technically, yes. There is a 0 there. So I can either say I don't have one, but I would say that my constant is going to be 0 because all of my small squares zeroed out. So there's really a plus 0. And then that's how I want you to fill out that particular handout. And I will check with this right here. And in your algebra tile, I want you to simulate those and make sure you know how to do it and fill out the rest of your handout and get ready for your exit ticket.